We brought a very special friend and a treat because we actually got him into an orange shirt for 20 minutes. Oh, wait a minute, this seminar's an hour. We got him in an orange shirt for an hour. This is Victor Tan. Victor Tan is a WPC enthusiast to the extreme. And he's going to cover WPC basics, and David and I, David is going to be Vanna White. I am not Pat Sajak, but we are going to interject fun things as Victor goes through things for you and with you. We'd also like to welcome in our new audience from Geek Gamer TV. So this is being streamed live for all of the mistakes that I've already made. And how many times did I say Victor?
Thanks, Doc. So I think I just wanted to start by covering what the basics of a machine are. Clearly there's a cabinet, electronics and mechanics. I think when I like to look at things and I think about it, how does it all work and how does it all fit together? I look at when the power comes in, what happens to the power from your wall, where does it go, how does it get distributed, and how does it finally make your machine provide you with entertainment, because that's ultimately what it's supposed to do. So let's start with a wall. There's 110 that goes in. There's a transformer that changes the voltages. There's some stuff in the back that deals with the electronics. There's a power board. There's a CPU board which has brains, and then there's sound, and then there's display. I guess from my experience and how I was trained, I like to think of it kind of like a body. There's a brain, there's a nervous system or the wiring that connects to all the parts, and then there's the mechanics that are your bones and muscles. That's usually how I like to think of it. So when I'm thinking about, at least when I'm dealing with problems, I like to break it down into electrical or mechanical. Those are the two basic broad categories that I like to think of. And then from that, I can decide which is what and where the problem is. The other thing that I think is important to me is that you need to know how things work normally before you can say, hey, there's a problem here. So understanding how it's supposed to work will give you an idea of where it's gone wrong. And how it's supposed to work is, there's two categories, there's electrical and mechanical. I think a lot of people can see the mechanical side of it. There's a bunch of metal, there's some screws that hold it together, or there's screws that hold it into wood. And then there's the electrical side, which I think is kind of daunting to a lot of people. I think for electrical, you can do reading on it, but because electricity is often unseen, it can be also dangerous. So just be careful before you start working on it. And some of the things inside and underneath on the playfield are high voltage. So I think they're about 50 volts, 25 volts.
In a WPC, Victor, you can actually have 75 volts. 75?
Yes, sir. It's not regulated, so I guess that's 75 volts not under load.
It's 75 volts AC is what it's. You have a 50 volt AC circuit combined with a 25 volt AC circuit that makes your 75. So it's not actually a true 75.
Okay. And there's also high voltage for the display, which you want to steer very clear of. That's like 100 volts and minus 100 volts.
Yes.
So be warned with that. The later WPCs have what they call a coin door interlock switch. So when you open the coin door, it interrupts the 50 volts. The higher voltage side of things. It still leaves the 12 and the 5 volts there, which won't necessarily harm you. If you do accidentally lean on the side rail and touch one of these 50 volts, you'll probably feel it. Probably won't kill you. You'll say, I don't think I'll be doing that again. But just as a warning, it's there. If you work on later machines, if you open the door, it's not there. If you then go to run your tests and things don't work, it's because you interrupted the 50 volts. You'll need to close the door or push the switch in. Those are the things.
Hey, David, what test doesn't work if you have that interlock open?
Oh, nothing much.
You know,
Star
like
Trek Next Gen.
The flasher test, maybe?
Yeah, maybe. A couple hours.
So your flash lamps will not work if the coin door is open and the interlock is not.
Yeah.
So that's a very common trap. People say, oh, I run the tests and things don't work. Again, there's a certain era of machines. I guess that's also another interesting thing to talk about, the history of the machines and the series of the WPCs. There's several of them, and they're kind of like an evolution. And I'll go back to the series before that, which is the System 11 series. You'll recognize those as the alphanumerics, things like Whirlwind, Black Knight 2000. At the end of that series, Williams decided that they would shuffle up the board set and essentially switch power and CPU into two separate boards. And when they did that, they created the WPC set. And the first few games on that are alphanumeric, Funhouse, Bride of Pinbot. And then they went to DMD, to dot matrix display. For those earlier ones, there is no coin door interlock. So that's the warning. Again, when you're working on these playfields, and you should know which series you're working on for your own safety reasons. The later ones, I think like Indiana Jones, Star Trek, the DCS series, they had it. So I guess that also is a good time to tell you what the different kinds of CPUs and systems there are.
Before you go there, Victor, on the WPC DCS series, such as Indiana Jones, which is a prime example, they had two safety interlocks, and one of them is a service switch that you can actuate with the coin door open. The other one you cannot, and what they did is they sent you a little yellow clip to hold that closed. And over the years, people didn't know what that clip was, and they found it in the coin box. They go, what the hell is this? And they tossed it. And it actually served a function. What that clip was for is to keep that switch closed for testing of the service technician. Those clips are not yet being manufactured. Marco Specialties is working, I believe, with Pinball Life, with Terry at Pinball Life, to get those remanufactured. Because in almost every DCS WPC, they're missing. You can use just about anything you want when what works really well is a potato chip bag clip. And because as soon as you close that door, that clip falls off, so then you don't get stuck screwing up your door.
The last thing you want to do is keep it permanently on without realizing it, because then you've defeated the purpose of the switch. So let's come back to the series of WPCs. The first few series that they made were called the alphanumerics, things like Bride of Pinbot, Funhouse, and they quickly went to the dot matrix displays, things like Terminator 2, Gilligan's Island. And then they moved to Adam's Family. And when they did that, they changed the way the flippers work. And this is another fundamental difference between the older System 11s and the newer WPCs. The older System 11s had 50 volts pretty much running through the flipper coils at all times. And when you press the button to actually actuate the flipper, you are closing a 50 volt circuit. So that's a high voltage button right there in the side of your cabinet. The high voltage is interrupted by what's called a normally closed end of stroke switch, so that when the flipper actuates to a certain point, it opens the switch and breaks the high voltage and breaks a short path to ground for current, which provides the power stroke. With WPC, like Adam's Family, which is the first of the incarnations, Williams went to a different system. They went to a Fliptronic system. It's completely computer controlled. When you press the button, the CPU, the program, recognizes that the flipper button is pressed, and it then sends the commands down to the flipper coil to actually actuate the flipper. The flipper coil is still high powered, but the button itself in the cabinet is low powered. And then they went to, they also changed the end of stroke switch from a normally closed to a normally open. There's actually several advantages to this. Firstly, there's no high voltage in the cabinet, but secondly, in the old system, when the end of stroke switches failed to open, they would short. And when they would short, they would cause the flipper coil to heat up and basically constantly energize, and you pretty much would blow your fuse instantly. You knew when that flipper fuse was blown, you go look at the end of stroke switch, it's probably broken or broken off.
Let me interject here, Victor. on the older systems where you have the normally closed end of stroke switch, when it opens, that 50 volts doesn't completely go away. That 50 volt circuit goes away, but then the 25 volt holding circuit, if you're still holding that button, then actuates. And where Victor says that this changed into a computer-based setup, it's actually being controlled, instead of by switches, you're using Optos. So you're breaking the Opto when you push in the flipper button, I should say. It breaks the Opto for the Fliptronics 1 and the Fliptronics 2.
And the CPUs read those differently. They're not actually physical switches. An Opto, which we should cover and get to, because William started using them in the later series of machines quite extensively. But for the meantime, so the Fliptronics, the other advantage of the Fliptronics system is that the switch is actually closed when the end of stroke is reached.
Run!
We're being attacked.
Don't rub on me, don't rub on me. Microphone. Apparently we just need to check and make sure you guys are still awake.
So the end of stroke switch is normally open and it's closed when the flipper reaches its end of stroke. And this is really just a signal to the CPU saying the end of stroke has been reached. The CPU itself puts, I think it's about 500 milliseconds of power, of the high voltage power, to give you the power stroke, and after that it cuts the high voltage and sends it through the hold winding, which is the lower power voltage, the lower power winding. The signal is purely to the CPU to say, hey, the end of stroke has been reached. There is also another added advantage, and this is why you really want your end of stroke switches on WPCs working, is that if the ball hits the flipper hard enough, it may actually cause the bat to drop. And when that drops, the end of stroke switch will then reopen. The CPU will see that and say, oh look, this guy was holding the button in, the flipper should be held up, the end of stroke switch came down, let me re-energize the coil. And it re-energizes the power stroke and it puts the flipper back up again.
Sometimes when that happens, that causes machine gunning. And your flipper just goes like this, and it makes a really nasty noise.
It's definitely important to have it, but it's not critical. You won't blow fuses, the game will still keep running, and that's the advantage of this system. The game still operates, and if you've got a machine out in a barcade, you want it to keep operating to make money. So after the Fliptronics series, Adam's Family is the first one. It has its own Fliptronic board, which is incompatible with all the other Fliptronic boards, called Fliptronic 1. And you can tell it's got, the connectors are numbered 800, not 900. They went to Fliptronic 2, which is the series that they used pretty much for the entire WPC series. That's the 900 labeled boards, from the Getaway all the way through to when they ditched WPC and went to WPC 95. The soundboard is kind of separated into two eras as well for WPC. There's a WPC, what we call pre-DCS, and there's WPC DCS. And DCS was introduced with Indiana Jones. DCS stands for digitally compressed sound. Essentially it's sound samples that they compress, decompress, and play the waveform, what everyone accepts as normal today. Twilight Zone, I believe, was supposed to be the first machine that had that, but they wanted to publish it before it was ready, so they went back to the pre-DCS and released the machine because they got to keep the pipelines moving. An interesting little tidbit, in case you want to know some detail about the flipper coils. There's two different sizes of coil stops, and the pre-DCS coil stops are, if you buy them, they're the gold ones, and the post-DCS ones are the black ones, and they're a little bit longer, so they provide less flipper travel. So sometimes I've seen people swap them in and out. Just a little bit of detail in case you're curious to know that that's a dividing point between the eras.
Well, what's the bad thing if you put the longer one in the one that requires the shorter one?
You just don't get as much travel. The game doesn't play.
It's also going to mushroom. And it could possibly mushroom your armature as well, which if you mushroom the armature and or mushroom the coil stop, you may have erratic movement or sluggish movement of that flipper coil or armature.
And the flippers for me are the most important part. They are the player's link to the machine. If the flippers play properly and operate properly, you feel that as feedback. If the slingshot doesn't fire, oh, no big deal. You didn't actually press the button to operate the machine, and that's that level of feedback that is so important when you play a machine. It's how you interact with it. So after the DCS system, they pretty much did a cost reduction, combined everything into what is known as WPC 95. They took the Fliptronic board, put it on the power driver board. They took the audio visual, the sound board and the DMD display board, and they put it onto one board. And that's a reduced chipset. And those are machines like Attack from Mars, although that's a remake, or Medieval Madness, the later series of machines at WPC 95s. But essentially, the electronics, the wiring, everything is pretty much the same. So let me move away from the back box towards the wiring, down toward to the cabinet. Williams had a system that they used for many, many years, and it persisted through to WPC. There are essentially 3 primary bundles of wires, and then in the later generations, there are 4 bundles of wires. One bundle is the power, drives all the coils and the flash lamps, and you'll see that, it's the thicker wires. Another bundle of wires that are zip tied together are the lamp wires, and they're always red and yellow. Another bundle of wires are the switch wires, and they're always white and green. And the fourth harness that you'll see is the Opto harness, and those are almost always gray, orange, or black in nature. And they're all zip tied together, and then the bundles are all held together with clips as they run through the playfield. So when you lift that thing up and you look at it, it's like, there is actually order to it. The order is those 4 bundles with those color groups. It's the one thing to remember. Don't get overwhelmed by it. So now we move away from that to the actual playfield, and then again, like all those bundles of wires all reach their destination. And another way I like to look at the machine is it's essentially those 3 things. It's mechanical for the assemblies, it's lamps to provide you feedback on what to shoot for or where to go, and then there's switches that provides input to the CPU program that tells it what actually is going on in the playfield. And that's pretty much like a video game today, right? You move the controller, that's input to the game provides you feedback by rendering a screen. Let's see, so Optos. I want to come back and cover Optos. There are 2 types of switches that are predominantly used in a machine. There's a micro switch or a leaf switch. It's a physical switch that 2 contacts actually close, or in the case of a micro switch, it's embedded inside the switch. You can't actually see the contacts close, but there's a button that physically actuates. And then there are Optos. Optos are optical switches. There's 2 ends to them. There's a transmitter that transmits an infrared beam that you can't see, but your camera can. So you can often take a photo to see whether there's an infrared beam coming out. And then there's a receiver end of the Opto, which sees and detects the beam and either completes a circuit or it doesn't. If the Opto sees the beam coming onto it, it transmits current through, and the voltage is 0. And the CPU says, oh, the voltage is 0. That switch is closed or open depending on the logic of how you want to see it. But basically the beam is not interrupted, is the easiest way to think of it. If the beam is interrupted, either by a ball or some other thing like a flipper opto interrupter for the cabinet button.
Or a hunk of dirt, which is very, very common with Optos.
Yeah, they do need cleaning.
Or a lamp in the trough.
That's true. So the Opto, we'll cover other Optos like trough Optos, remind me, but the Optos are used everywhere where Williams decided it was kind of I guess a cool thing to do, because sometimes I don't know why they use them there. But essentially there's a beam, and if the beam is interrupted, the CPU detects it. Very much like when you roll over a wire form and the micro switch is closed. It's exactly the same thing, it's purely digital. The other issue with the Optos is that they're powered off of the 12-volt unregulated supply, which is different than the physical switches, which are powered off of the 12-volt regulated supply. So often you'll see people say, I have a problem with my Optos, but all my other switches work. It's because they're powered and detected differently. But the CPU still sees them as one big 8x8 switch matrix as far as it's concerned. It treats the game logic treats them the same. So the other thing that Williams did is they didn't just use the two separate Optos enclosures like a transmitter and a receiver. They used these slot U-shaped embedded Optos like you'll see on flipper boards, or in things like the Twilight Zone clock, or the Theater of Magic trunk, or the Indiana Jones Path of Adventure, or the Addams Family thing. Essentially, there is a motor that moves around, and an arm, and an interrupter that moves with it. And when the interrupter interrupts that U-shaped slot Opto, that's the same thing as a transmitter receiver, except it's all in one. There's also a subtle wiring difference between that. The standalone Optos go to an Opto board, and those Opto boards are either 3, 7, 10, or 16, depending on however many they chose to use. The U-shaped slot Optos are actually placed onto the switch matrix directly. There is no comparator in the circuit like there is on that Opto board. So again, you need to know what kind it is that you're dealing with and where the potential problem might be. But this comes back to the thing that I started originally by saying you need to know how it works and how it's wired in order to know where to go look for the problem.
Well, those U-shaped Optos have been used for many years in drop target banks, especially 3s, 4s, in just about any System 11, System 9, that's any System 9 forward. Your drop targets are mostly those U-shaped Optos. The funny thing about those U-shaped Optos is that Opto itself runs about $6 or $8. And before Radio Shack closed, you used to be able to just buy a pair and you make your own. And that was like $1. But now Radio Shack's gone, so.
There is a replacement part for those. For a long time, and I don't think this applies to Twilight Zone, but the other regular ones, there is a replacement part. Vishay makes, I think it's a TCST 1103. So
sounds right.
If you need them, they do remake them. For a long time, they were tough to find.
Yeah.
So let me cover one more thing with Optos. Trough Optos. So this is an interesting area because Williams, when they first, like I said, they really enjoyed Optos. Like, oh, let's go use Optos everywhere. If you look at earlier pre-DCS machines like Twilight Zone, Addams Family, you'll see that there are two coils that they use to get the ball to feed into the shooter lane. There's one, when the ball drains, it drains into the out hole. Then there's a coil that kicks it over a kind of roof-shaped metal structure with a gate that stops it from coming back. And it sits in that case, gravity-fed 3 or 4 trough placements, trough with 3 or 4 switches. And then there's another coil that they use to kick the ball out into the shooter lane. When they went to games like Indiana Jones, the first incarnation of what they call the gravity-fed trough, basically the ball drains into this big metal contraption that gravity feeds it down to the bottom, and then there's just a single coil that pushes the ball up and out into the shooter lane. As part of that big metal contraption that holds all the balls, they put Optos in there. So the ball falls into it and it interrupts the beam. The problem with these initial incarnations is they put these honking big 2-watt, 220, I think, or 270 ohm resistors in there, and those things just dissipate heat. They get hot really quickly. And when they do that, they also melt the solder that joins them to the board. And when they do that, they develop cold or cracked solder joints, and then they don't work, and then your game logic gets very confused, and it says, where's the ball? Because it can't see it, and it feeds another ball into the trough. It's like, where's the ball? Oh, it kicks another ball out. So if you see this problem on Indiana Jones or Star Trek, which are notorious for these kinds of issues, that's the first place to look. So Williams got a little bit smarter afterwards. I guess many operators complained about this, and they changed the trough Opto system, and they removed the big 2-watt resistors and put them, and basically used Optos on the boards that are underneath the playfield. The important thing to know is that there are 2 types of Opto boards, and they're not compatible. So if you buy a 7 Opto board, if it's one of the older games, you need to have the 220 watt resistors on it because there's no other circuitry for that emitter. If you buy the wrong one, it won't work. So again, this comes back to you need to know how it works normally and what parts to get your machine working properly. Okay, so that covers pretty much, I'm guessing, all of the basics of the wiring.
Hey, Victor, can we touch on Optos a little bit more for
Sure.
the trough? Recently, what David and I have been seeing quite frequently is that people have a problem that they don't understand that a pinball game is a sealed system. Unless you have a big gaping hole that drops to the floor, that pinball did not disappear. And when it comes up and it says pinball missing, people have a tendency to put a ball in. And when it comes up and says pinball missing again, they put another in and another until it stops saying that. Now they have anywhere from 2 to 3 additional balls in the trough. And then their complaint is it's kicking how many out into the shooter lane?
2, 3, 5.
2, 3, 5.
It's going to keep kicking until the trough has the number it expects to have in there at that point.
Which comes right back to what Victor was saying about you have to know what it's supposed to do or supposed to look like before you can say you have a problem. And I can't emphasize enough that if it says pinball missing, it's in there someplace. You just have to find it.
It might be hidden like you wouldn't believe.
Not finding it can be a very bad thing because sometimes when you're in multi-ball and a sling kicks, there's enough gap in there that ball can jump the rubber and end up behind the sling. And you know, you don't normally see it until you pull that sling plastic and you go, there's a ball here. Oh, well, it's not missing anymore, is it? Or sometimes they get stuck up on a non-strong pop bumper, where they will just sit up on the back of that guy and you know, nobody sees it. And, well, okay, let's put another ball in it. And eventually it comes out.
Yeah. Well, so this actually happened with me.
We've got a question back there, Victor.
I have a getaway, and I've seen if you get all 3 balls into the supercharger, sometimes one of them will fly out and back behind you to the end of the playfield, one at the bottom of the cabinet.
There's a piece missing. That shouldn't be physically possible unless there's something missing or broken.
There is a deflector that is supposed to be there that keeps that from happening. And he is right, you are missing a piece.
If you look at a pin, you go, why the hell did they screw that plastic there? That kind of thing. They're en route, they found that operators were like, well, we're getting a ball stuck here. We'll put a random, often clear plastic on this post that, like, well, why? Well, it's to keep the ball from sitting there.
A lot of times it's a post that would normally go underneath a plastic, and it may or may not have a rubber on it.
Yeah. The term I've heard people use is a ball trap. Basically, the ball, you look around the playfield and you wonder why that's there. That's exactly the reason. In testing, when they develop it, or out in the field, as an operator has used it, they put all these weird and wonderful little pieces of plastic there for that exact reason.
Yeah, you're just missing a piece. And it may not be in the manual. It might have been in after development.
One of the best things you can do when you figure out that you are missing a piece, or it could be a broken piece. So you may have part of it, not quite all of it. One of the best things that you can do is go to ipdb.org, which is Internet Pinball Database. Most of all of the pinball machines have pictures of the entire play field, and some of the pictures are good pictures. You know, they're 1280s or above, and they're of just the upper section or the middle section or the bottom or whatever, you know, and then you can compare to what was there and say, oh, I see, it's right there, you know, and that's very helpful.
But even if it did fall behind, unless you had a rat, it's still in the machine.
Yes, it is.
Somewhere.
Yes.
It can end up in the coffin portion. It's not supposed to ever be able to do that.
So there was one thing I wanted to add as well with this pinball missing. There's two things. When I think last year when my Monster Bash came, someone came and grabbed me and said it's kicking out 2 balls, and somebody had actually put 6 balls in there when they should have put 4 in. And again, this plays to the logic. There's 4 Optos for 4 balls. The game kicks 1 ball out, it still sees 4 balls. So it kicks another ball out until it sees 3 balls, and then it says, okay, I'm good. That's why it'll just keep kicking multiple balls out. The second thing I wanted to cover, which is important, is the number of balls. So there's a little sticker inside when you lift off the lock bar. There should be a sticker there that says install number of balls.
That zone,
now,
this balls and 1.
If that sticker is missing and you don't know how many balls goes in there, count the trough switches. If you have 4 trough switches, you require 4 balls. If you have 3 trough switches, you require 3 balls. If you have 5 and an Opto, you require 6 balls.
Unless you're Twilight Zone, because it counts what's up in the gumball machine also.
Yeah. Yes. Install 5 plus 1 ceramic.
That is the one oddball. The other thing about Twilight Zone is if you do not load the balls correctly, it won't work. It'll keep kicking balls around and kicking
until it's loaded in the way it wants it.
Yeah.
A little like Star Trek, it likes to stage balls, and if it doesn't stage the balls, it is not happy.
Next gen.
Soon. Very, very soon.
So the other thing I wanted to point out is that Williams went a little crazy about 93, 94 with their number of balls. Twilight Zone having 6, Indiana Jones having 6, Star Trek having 6. They kind of toned back on that by the time they got to WPCS games like Theater of Magic, which only have 4. It's important to note that don't put 6. Don't assume that all the games have 6. There's only a certain number that have 6. Most of them have 4. And as Doc was saying, check the number of Optos. Case in point, World Cup Soccer on right out there on the floor, it had pinball missing. There were only 4 balls in it, but there were 5 switches for the trough. So there really was a ball missing, and I went and looked it up on IPDB, and it said this game is a 5-ball game, and yet there were only 4 balls in there. So I got another ball and I put it in. It's a happy camper. Yeah,
and unfortunately, IPDB, they give a pretty good description of most games, and they'll tell you how many flippers and how many drop targets, how many pop bumpers and ramps and all that kind of good stuff. They don't always tell you how many balls, and that's where it comes back to count the trough switches. Yep. Or trough Optos.
There is one other thing actually that I just thought of as well. There is what they call a trough jam switch. It's a switch or an Opto just above the ball 1, and that's in case the ball kicks out, the next ball is gravity fed, but the ball doesn't go all the way out into the shooter lane. The game knows that the ball's jammed up there. It should always be not closed or open, the logic that the game sees. That's another one that's important to know. It's there. So speaking of all of this, I actually just suddenly thought of another important point that I really wanted to emphasize. Use the game tests. The game has built-in diagnostics, tests for everything. Use them. You want to test whether a switch works? Okay, that's fine. Let's alligator clip the 2 portions of the leaf, put the multimeter in continuity test, and close the switch. Okay, the switch works physically. But that doesn't matter because how the game sees the switch in its CPU logic is all that matters to whether the game will work properly. So if you go into the switch test and you actuate the switch and the game doesn't say the switch closed, but it closes correctly with a multimeter, it doesn't matter. If the game logic doesn't see the switch close, then it's not going to work.
Well, the same thing comes back to what Victor said about know what to expect. So when you have the switch matrix pulled up and it has all these little boxes and you see dots, well, a dot means it's closed. And so you should also be able to see that change. As you're physically moving that switch, it should go dot, no dot, dot, no dot. And that's what you're looking for. And it'll let you go through each one of those switches all the way across in the tests.
That's the number one thing I can't emphasize enough. I see people post on forums like Pinside, help me, this is broken, it doesn't work. But they didn't run the switch test or the coil test or the whatever else. You have to run the tests because that's going to tell you what the game logic sees and therefore what the decision is that the game logic will make. And if it doesn't see the correct thing, it won't make the correct decision, the game won't play correctly, you will not be happy.
Hey, Victor, let me see your CPU for a second. So, in as much as testing the switch matrix, David and I covered this a few years back, one of the biggest problems is that when this is the actual CPU, and of course there's quite a few components missing. When the batteries go bad, they sit right above a ULN 2803, and that controls the majority of your switch matrix. In conjunction with, that controls all of your columns. What controls your rows are over here, they're LM339s. Well, the ULN 2803 sits right under the batteries in the corrosion zone. And when your batteries get into the corrosion zone, and David, you can hold that on the camera so everybody can see that a little better. It'll kill that 2803. And what Williams did initially is they soldered that directly to the board. And then they went, oh, people aren't changing their batteries and it's eating this 2803. And so then they socketed it in the later versions. So if you have switch matrix problems, 9 times out of 10, in a WPC, it's going to be the ULN 2803. Rarely will it ever be the LM339, either one of them, because there are two.
The other common thing that happens with the 2803 is, well, people are working with their machines on, yes, don't do that. You will accidentally short a 50-volt coil to a 12-volt switch. And when you do that, you'll send 50 volts through that 2803 and it will not be happy, and neither will you, because you will be smelling burnt electronic components. It will happen. It's common. It's
it smells like money in the morning.
It does.
I've done it. Everyone will do it. The other reason that you want to turn the machine off is you'll blow, say, like you'll touch to the GI and you'll short the GI. You'll short something. It'll happen. There's lots of empty open wires inside underneath that playfield. Turn the machine off. You'll be much happier. So to come back to the tests, that was the one thing that I really wanted to emphasize again. Run the tests. Get comfortable going into test mode, playing around with it, hitting switches while a switch test is up, running through the coil test, running the flipper test, running the lamp tests. If you get comfortable with that, you can pretty much use those WPC, the WPC, you can diagnose problems on WPC family members of machines because they're all the same. Sure, the game-specific switch is there, you can go look that up in the manual, but the tests are all the same and they all behave the same way.
A switch matrix is a switch matrix is a switch matrix. Lamp matrix is a lamp matrix is a lamp matrix. They're all 8 by 8. They're 64 lamps. Whether they're all populated or not is a different story. You know, whether it's, you know, a different insert that it lights up, that definitely. And the same thing with the switches. They're 8 by 8. There may or may not be 64. They may only be 61. They may be 59. But there's 64 capable for both, and they're all the same.
And this holds true for System 11 and previous era machines as well, but the tests are slightly different.
Yeah.
So the question is, have you talked about the high-low tones? Are you talking about logic probes?
No, the sounds on the switch test in WPC. I just learned about it really helpful.
I guess you can teach me something. I don't know anything about this.
Yes, you scroll through your switch test, it gives you either a high tone which says things are fine, or a low tone that says this is not as expected.
I've never noticed
That. That's not as reliable as the visuals that you're going to get.
I agree.
And of course, when you're hearing impaired like I am, And, you know, I mean, as soon as we opened the doors today, I had people talking to me, and all I see is their lips moving. And so, you know, I'm up in their bubble going, oh, you know. And so those tones, unfortunately, you know, in any kind of game room environment, I can't hear those tones. And even if I turn the volume all the way up, I still can't hear them. So it's, the visual is a more accurate, because it doesn't have to go through the soundboard. You know?
The game will give you an audio indication that the switch is hit. Yeah. And it will give you the information of what wire colors and everything. And that's usually what I do. When I'm underneath the playfield, I've lifted it up, I just listen for the boom, boom, boom sound.
In actuality, what Chris is talking about is when you make that switch and the dot comes, or when you unmake it and the dot goes away, that's the tones he's talking about. It makes that tone when you, I know exactly what he's talking about. Yeah, I know what you're talking about.
So there's one more thing with this board and what Doc was saying that I really want to emphasize. Batteries. Either change them religiously.
Evil.
Either change them religiously, remote them,
and
get them off.
The best thing that you can do for those batteries is pull them, throw them away, and cut the battery holder off so that someone does not try and reinstall them. And the reason I say cut it off is because sometimes when you desolder it, the traces are so thin and weak that you'll tear up a trace that needs to be there, and then you'll be chasing
even the start of leakage, you're just looking for trouble. If you just cut it off, you'll have little divots, you know, little bits left over. They're not going to hurt anything, and you'll be able to see once you get that off, because it covers this whole area. If you're starting to see discoloration, you have acid damage you need to treat, because taking the batteries off isn't going to stop what's already on the board. You've got to treat it and get rid of that so you don't continue to etch out the traces.
These particular CPUs either use a 6264 or a 62256 CMOS RAM.
Lives up here.
Okay, my recommendation is that, again, when you remove that RAM, because 9 times out of 10 it is not socketed, cut it off and then desolder the legs. You have less chance of damaging.
Remind me, we need to make a video of doing that.
Yes. You have less chance of damaging any of the traces when you do that. And the reason that we say to go to the NVRAM is the NVRAM has its own internal battery that's supposedly supposed to last 100 years or something stupid that is BS. And it will never leak acid onto your board. NVRAM, if you buy them in quantity like we do, we being David and I, we get them for about $10 a piece. No, we don't buy them in the 100 or the 1,000. We buy them in tens. Okay, if we were to buy them in singles, they run about 20 bucks. So 20 bucks to save a $300 board over some $4 batteries that you've got to change twice a year minimum. If you're going to keep batteries, which you should not do, just like you do your smoke alarm. You know, when daylight savings changes, change your batteries. I fix these damn things and I forget my batteries. Of course, if you use Kirkland batteries, you're okay because they don't have any acid in them. Ask Doc. Thank you, Doc.
On the battery thing, if you can't have the skills yet to do the NVRAM change and the remote battery.
Sure.
I've heard putting lithium batteries in.
Lithium batteries are going to.
They work.
You can't. You've got to be careful though.
But again,
lithiums will leak also. Yes. They will leak a different composition. It's going to react with any previous acid because you're actually going from a base to an acid. You're going to get weirdness. You're going to be very careful with a lithium battery because alkalines are 1.5 volt. Lithiums aren't always, unless you get some very specific battery. So just be careful. But even lithiums aren't a solution. Lithiums they're a temporary fix. But I'm going to throw you out. I'm going to throw out a shameless plug here.
And the shameless plug is that if you buy an NV RAM from Rob Anthony, Lockwind Lit, right inside, he will install it for you for free here at the show. Then you don't have to worry about your skill set.
Or if you really don't feel comfortable, we'll do it. It's going to cost you $50 plus the part, but we're all going to do it. And if we lift the trace doing it, we're going to fix it before we give it back to you.
Yeah.
That's the one thing with these boards. The traces on them are really, really tiny. If you don't know what you're doing, you may damage the board. And it's
even if you know what you're doing.
I've lifted traces.
Yeah.
It's going to happen. It's 20-year-old solder. That's
20-year-old solder, and if you've had any acid corrosion, it's getting under those traces and pulling it off the fiberglass. It's just, you just got to be careful.
That's the one thing I really wanted to say is don't work on the boards if you don't know what you're doing, or get help. Right? There's plenty of people here that are willing to help you. Just don't overestimate your confidence level, otherwise you'll end up with that. Jumper wires everywhere.
And again, don't underestimate your confidence level either. Okay. One of the things that we started back in 2010 when the show was in Seattle was something called repair parties. And the reason I started repair parties was because we were fixing way too many games when they came in the show, and they just were not standing up to being played. It wasn't bad quality games. It wasn't anything on the owners. It's, the reality of the situation is a repair party. They were all at my house, and now they've gone as far south as Olympia, Lacey, and as far north as Cedar Woolley, Mount Vernon, and as far east over as Spokane. So what a repair party is the group is willing to teach you how to fix your equipment with the parts that you provide. We're not willing to make the repair for you. We are willing to teach you how to do it. Okay, now if I make the repair for you, if you show up and bring me your parts and I make the repair, I'm charging you. You show up, I will show you how to do it, I will make sure that you do it correctly, and it's free. Now, in the instance that you show up and you don't have something and you thought you ordered everything and I have it, I will loan it to you. I'm not going to sell it to you. I don't sell parts. That's Marco. That's not my job. I will loan it to you and you will replace that part.
I have a shop, so.
Yeah. He will sell you the part. I won't. I don't want the money for it. I want the part back.
What's the best way to hear about these repair parties?
The best way to hear about the repair parties is to join the WPC 2006, which is Washington Pinball Crazies 2006 on Yahoo, and or the Smack group they're on Yahoo as well, right?
Yeah.
I'm sorry, Google, excuse me. And that is the Seattle Metro Arcade Collectors. You can also hear about repair parties on the Northwest Pinball Show Facebook page, which I believe is NW Pinball, I think, on Facebook.
Yeah.
And we hold several repair parties throughout the year, and it's whoever wishes to hold one in wherever, and there are at least 2, if not more, senior techs always present. So you can get almost anything that you want answered or fixed. You don't have to have something broken to attend. You don't have to have something to fix to attend. You can come watch and go, hey, that was cool. Or, hey, can I try that? Sure, go right ahead.
It's what I did. I just went to a party and said, I want to learn. And people will teach you if you want to learn. People won't do your work for you. It's that age-old saying, I'd rather teach you to fish than give you the fish.
Exactly. In my book, learning and helping people learn is free. If I'm doing it for you, nah. My time's worth $90 an hour. Sorry.
I've been doing this for more than 20 years. I've got a degree from Barnes & Noble. I'm self-taught. I've learned from others. It's how you get there. You know, I dedicated a ton of time into learning. I've made a lot of mistakes, and I fixed a lot of my own shit.
But again, it comes back, because I'm sensing we're getting close to the end. It comes back to you need to know how it works normally. To do that, you've got to learn. That's not something that's going to magically happen. The joke I make is, this isn't the Matrix where we can magically teach you how to do jiu-jitsu in 10 seconds. It's not going to happen.
Kung Fu. Kung Fu.
Oh, Kung Fu, sorry. You have to invest the time in it for yourself if you really want to learn. But there's plenty of resources here to help you. Absolutely happy to help, just ask. Are there any other questions?
Yeah, every year it's kind of fun. You know, we have the command central in the middle of the hall. The reason we have command central in the middle of the hall is so that we can accurately dispatch repair techs out faster to the corners of the hall. And you know, many people come up to us separately and individually as we're standing there looking at each other going, well, what's next? And they will ask us specific things about a specific game and or who repairs this or who repairs that. You know, and there are certain things that I don't work on. I do not work on Gottliebs. I hate Gottliebs. Don't like to play them. Don't
You're
like
going to help me
work
with my haunted house.
Yeah. But I know a guy that will work on them, and I can point the finger. You know, or a guy that has a safe cracker, I can point the finger. You know.
My open invitation here is, if I'm on the floor and I'm working on a machine, feel free to come and ask. I'm happy to teach you, I'm happy to explain to you, but you have to want to learn.
Yep. Shoot.
Is any switch in the matrix when you go into test? Is anyone that's always closed all the time?
Yes.
Quite possible. And that's on your matrix in the manual. You'll see NO and C. Usually, in
Like shaded, isn't it like a shaded?
Switch 24. It's always closed. The reason why the Williams engineers did this is because it tells the CPU that there's 12 volts regulated going to the switch matrix. It knows that the 12 volts is present. If the 12 volts isn't present because that always closed switch is not closed, then it says there's no 12 volts. If there's no 12 volts, no other switch is going to work. So it instantly can alert you on power up, hey, this always closed switch isn't closed. It should be. There is something wrong. It's switch 24. It's always closed. So
and in Twilight Zone, there's you'll have the stuff in the gumball machine. If it's loaded correctly and you go into test, there's going to be things that are showing closed. If you had emptied the gumball machine and we're doing the tests, it's going to be open. But in normal operation, you're going to see closed switches there.
And the Optos are logically closed if the beam is not interrupted. So if you empty the balls out of an Opto ball trough, those switches will register as closed on the switch matrix. The CPU inverts the logic. But if you're talking about pure physical switches, those will stay open. And in a game with pure physical switches, only switch 24 should be closed.
Now, if you get a switch that's like, well, that seems backwards, most switches, micro switches will have 3 legs. There's a common and a normally open and normally closed. If you've wired to the wrong side, the switch is going to be acting backwards.
And so sometimes you're going to find on those micro switches that David's talking about with the 3 legs, what they've done is they will take a diode and they'll run it from the normally closed back to the common, and then you're actually hooking up to the normally open. So they're using all 3 legs of that switch.
The green wire usually goes to normally open.
Yeah.
The banded end goes to the common, and then the white wire goes to the normally closed.
Yeah.
That's usually how they wire them.
Why do they do that? So that the switch goes closed for some reason?
No, in a matrix, every switch has got a diode. It's how it does the actual matrixing. And so you need a diode in there.
It's trying to keep the false active of another switch when that one actuates.
It's separation.
Yeah, it separates that switch out so that, you know, if switch 24 goes, it doesn't trigger 25 because they're daisy chained together.
It's how you get 64 switches out of 16 wires.
Yeah.
Yeah. And switch 24 that's always closed is exactly that, a diode. That's all it is.
Okay, so we've only got a couple of minutes left, and we're going to call this a wrap. And I would definitely like to thank Victor Tan for coming and sharing with us. And even though Victor will not be in an orange shirt after this, because I'm sure that he's going to race to the bathroom and change it, he will be out on the floor and still will be willing to chat with folks that are willing to learn. David and I will both be here someplace. Hopefully I won't be hiding anywhere, but you know, I never know.
It happens.
And I'd like to thank all of you for coming, and thank Geek Gamer TV audience for joining us. It's a pleasure to have everybody. And that's what we have on WPC Basics. And the one question that most people ask that we always forget is, what does WPC stand for? It's Williams Pinball Company. It means nothing. That's what it stands for. Thank you.